NASA has created the most powerful telescope ever that will change the way we view our solar system and distant galaxies. On December 25th, 2021, the James Webb Telescope was launched from the Arianespace ELA-3 launch complex at Europe's spaceport, which is located near Kourou, French Guiana. This location is vital as it's near the equator, which gives the telescope an extra lift into its journey through space. There are a variety of different components that make the James Webb Space Telescope so amazing. To preface, a telescope's primary function is to gather as much light as possible through its mirrors, as this is what determines how much detail we can see. So the bigger the size of the mirrors, the greater the discoveries. This is the main function of the primary mirror on the James Webb Telescope. It is made of beryllium, which is a lightweight and strong material. What makes it so unique as opposed to the primary mirror on the Hubble Space Telescope, for instance, is that the James Webb's one is made of 18 different hexagon segments. Now, there are two reasons behind this. The first one is that it's foldable for deployment, making it easy to compact within the rocket. The second is the more important reason, and it's that there would be no gaps in between the hexagon shapes as opposed to having square or circular shapes, so we can focus the light in the more compact areas of the detectors. The secondary mirror acts in a way where it reflects the gathered light from the primary mirror back into the devices of the telescope. The sun shield is vital as it acts as a cooling system for the telescope by not allowing sunlight to directly hit the devices and electronics. It has 5 layers to it to radiate out all the sunlight better. The solar power array always faces the sun to collect sunlight and convert it into power for the telescope. The last and arguably most important part of the telescope is the Science Instrument Module, or the ISIM for short. It is one of the most important parts of the telescope because it contains the near-infrared camera, the near-infrared spectrograph, the mid-infrared instrument, and the infrared imager. Those 4 components are what allow us to see the most spectacular and beautiful images of our own solar system and distant galaxies. With such a powerful telescope, there are bound to be some amazing discoveries. So let's dive into some of the current missions of the James Webb Space Telescope. The first mission to highlight is the discovery surrounding Saturn's moon Titan. To start, scientists and astrologists alike are always searching for connections to our home Earth. What makes Titan so intriguing is that it is the only other object in our solar system that has rain and liquid-based features on the surface like oceans and rivers. Because of those features, scientists are looking for new discoveries that can lead to vital information surrounding Titan's thick atmosphere, which, like Earth's, is made of mostly nitrogen, and it's unique from its nature that it is the only moon in our solar system to have a prominent atmosphere. In early November 2022, the James Webb Space Telescope captured images of Titan, revealing not only 1, but 2 visible clouds, one even being above Kraken Mare, which is Titan's largest sea. To many, clouds are nothing extraordinary. However, to Titan, they are nothing less than extraordinary, as by studying them, scientists can learn more about Titan's thick atmosphere and its unique case of liquid-based surface features. By studying that, we not only learn more and more about its unique case, but we can add some comparable features that may help us understand our own atmosphere on Earth even better. The second mission to highlight is surrounding LHS 475b, which is the first exoplanet confirmed by the James Webb Space Telescope. As I said before, scientists are always on the lookout for objects that resemble Earth in any way. LHS 475 follows this because it is a rocky planet that is almost the same size as Earth. It is located in the constellation Octans, which is 41 light-years away, and it orbits its red dwarf star, LHS 475, in just 2 Earth days. From its exterior similarities to Earth, scientists may view it as a future habitable planet and want to further study that possibility by examining its atmosphere. The James Webb Space Telescope is the only telescope capable of these studies due to its near-infrared spectrograph to measure the spectra of the atmosphere on LHS 475b. This is the transmission spectra of the initial data collected by James Webb. From this, scientists were not able to directly state that any element is present. However, they were able to rule out that the exoplanet cannot have a methane-based atmosphere. This is represented in the image by the green line. Scientists seem to have two prominent hypotheses. One is that the exoplanet has no atmosphere. This is represented in the image by the yellow line. And the other is that it has a carbon dioxide-based atmosphere. This is represented by the purple line in the image. Determining those theories, however, requires further research because carbon dioxide is much more difficult to detect. Although there is no definite conclusion, we are further in research in finding Earth-like planets than we ever have been. From its nature of being the greatest telescope ever created, many wonder what is next. Although the James Webb Space Telescope was created to view the outskirts of our solar system and the distant realm of space, scientists have been looking to capitalize off its amazing infrared capabilities. They allow spectrographs, a tool that examines how much light is emitted or absorbed by different things in our universe, to view wavelengths longer than that of the human eye can see. This effectively allows us to view details of our solar system that are still unknown to scientists, leading to potentially life-changing discoveries. Scientists have even begun to discuss using the James Webb Space Telescope to further study the biggest planet in our solar system, Jupiter. Specifically, they are hoping to learn more about how Jupiter's rings formed and its moons Io and Ganymede because of the rising vapor plumes that exist. On Io, these are most likely from volcanoes since it is the most volcanically active body in our solar system. However, because of the icy surface on Ganymede, scientists are wondering if the vapor is water vapor, which could lead to signs of life. All in all, the James Webb Space Telescope is the most powerful telescope ever created. It has already exceeded our expectations and discoveries and will continue to dominate in our understanding of space.